Section 1.5 is the last section that we're going to review from the previous course. Keep in mind, I don't want to scare you off. We are going to go over everything that you learned in your beginning and intermediate algebra. We're just going to go more in depth. So you're going to see a lot of repetition. But these are the two sections that stand out as the most challenging to students in this class. We're going to go over and review a lot of stuff with you, but these, we're going to assume that this is the review, and from now on you're going to know how to do those. Factoring is a key. Anytime there is factoring, we assume you could factor any problem in no time. So, I'm going to review factoring with you in full details. Factoring, anytime you see factor, there are two steps to factoring every time. Step number 1, you would look for a greatest common factor. Step number 2, and that's the lengthy case, you count the number of terms. Let me check. Okay, I was able to get this from my other Math 3 notes. So, step number 1, greatest common factor. Step number 2, you count the number of terms. If you happen to see 2 terms, then you're looking for 2 squares with a minus. If that's the case, you would write them without the squares. So you would ignore the squares and you will write the x and the y twice, 1 time minus, 1 time positive. If you see 2 cubes, you would write them without the cubes. If it's a minus, you copy it down, you square the first, you square the last, and you multiply those two. And this is always positive, this sign is always the opposite of that. And if you see 2 cubes with a plus, you write them without the cubes, square the first, square the last, and multiply those two. This is always positive, this sign is always the opposite of that. And you should know that this right here and this right here, both of these are prime, meaning they don't factor in R. Now I want to do a bunch of examples. Well, let's clarify the rest. What if you have 3 terms? 3 terms, you use any method that you learned in a previous class. There are 5 ways of factoring 3 terms. And 4 terms, you use grouping. It turns out roughly 70% of the time you're dealing with 3 terms. 25% of the time you're dealing with 4 terms, with 2 terms, and 3 terms, 4 terms grouping you barely see. That's why students forget about those. So we want to review all of those, and I'm going to do them in order. So in our book, I'm going to pick some problems, and I'm looking at page 62. That's where the homework is going to be. Directions, and number 1 through 62, which is the majority of the section. Factor each polynomial completely. So I glance at number 2, and my first order of business, greatest common factor. Step number 1, right there. Greatest common factor, I noticed they're all even. I could factor a 4 out of all of them. They all have an a, I take a to the least power. They all have a b, I'll take b to the least power. And if I divide those now, that would be a 4a plus 1 plus a minus 3b minus 1. And even though those are 4 terms, I do recognize that there's no way of grouping those. Basically, I'm done. Since this doesn't satisfy the grouping, there's no way of factoring that further. I'm done right there. So what's factoring? It's changing addition and subtraction into multiplication. Now, I'm going to take number 4 and put it right. Actually, let me put it right next to it. That's okay. So, same deal. I'm glancing at this. I notice They're all even. That's good. That means I could take a 2 out of this. I notice there's an x cubed, x squared, and an x. I could take an x out. I notice this is 2 minus y, this is 2 minus y, but this is y minus 2, the exact opposite. I could think of this as 2 minus y if I change this from a positive to a negative. And now I could say, let me take 2 minus y out of all of those. Now, if I take this and divide it by this, I'll have a 3x squared left. If I take the second term divided by this, negative over a positive is a negative, a 4x. And if I take a negative 4x squared into 2 minus y divided by this, I'll get a negative 2. Now, I do notice this is 3 terms. I need to factor that. I need to figure out, can I factor 3x squared minus 4x minus 2? So, 3 and 1, 2 and 1, 1 and 2, subtract to get me a 4. 3 minus 1 doesn't work. That's not a 4. 6 minus 1 is a 5. So that's prime. And we'll do a lot of the 3 terms coming up. Don't worry. So this is how I factor. You could factor anywhere you like, however you were taught. And I'm done right there. Now just to fit them in, I went up and I put number 6 up there. I noticed number 6 hold the same. This is y plus 3, this is y plus 3, this is the opposite. If I factor a negative out of that, that will be a y plus 3. The price is that you have to change that to a positive. Basically, you multiply it by a negative. Now if I look at this, I notice 15, 40, and 10, they all have a common factor of 5. They all have an x, and they all have a y plus 3. Out of the first term, I'll have a 3x squared left. Out of the second term, minus 8x, and out of the last term, a negative 2, and there are no factors of 3 and 1, 1 and 2. 6 minus 1 is 5, that's prime as well. There it is. I just transformed this from addition and subtraction to multiplication. If I take number 8 as the next problem up, I'm looking for a greatest common factor. 8, 14, that's not working. How about m? They all have an m. M to the 1 is the least power, n squared. That would leave me with an 8n cubed n squared minus 14m plus 2n minus 7. That's it. And grouping those wouldn't get me anywhere, because I do notice there's nothing I could do to make that a 2 and a 7. So that would be my final answer. Now when I get to the next set of problems, those are the 4 terms, but before I get carried away, I would always look for, one, are they in descending order from highest to lowest power, and is there anything common in those? No, there isn't. So I use grouping. I group the first 2 and the last 2. What's common between the first and the second? Y squared. That will be 2y plus 3. And if you take that negative out and a 2 out of those, negative 4y divided by negative 2 is 2y, and a negative 6 divided by negative 2 is a positive 3. And do we notice that this is common in both? You could factor that out. So 4 terms, you use greatest common factor twice. Out of the first, you'll have a y squared left, and out of the second, you'll have a 2 left. Now, it's true. It is true that this is 2 terms, but is it a perfect squared and a perfect squared? Y squared is a perfect squared, but 2 isn't, so you're done. Otherwise, you have to factor more. And let me get some more problems. Alright, now we're looking at, and this book does that, they really split this individually, which is fine. 4 terms. 4 terms, like we said, you use grouping. First step in factoring, greatest common factor. Nothing common in the numbers because 3 and 7 are prime. They don't have a y. It is in order. The greatest common factor is y squared. That will be a 7y plus 3. Take a negative out. 56 and 24. This kind of gives you a hint. 6. Negative 56y divided by negative 6 is 7y. Negative 24 divided by negative 6 is a positive. Uh-oh, that's not working. I'm sorry. 56 and 8. What is wrong with me? I'm really weak with math, you guys. You gotta help me out. So then I noticed that this is common in both. I could factor that out. And what's left is a y squared and a minus 8. And since this is not a perfect squared, I'm done right there. Otherwise, I'll factor it further. Number 14, the same deal. I glance at this. Is there anything common? 6 and 8 even? Even? That's not even. And m, nope, not all of them have the same thing. So I'll try and take the greatest common factor out of the first two. Wouldn't that be a 2m? And I'll have a 3m plus 4n left. Take that sign 95% of the time. 12 and 9, 3 is common. 12n divided by 3 is 4n. And negative 9m divided by negative 3 is a positive 3m. We notice those are the same. I could factor out a 4n plus 3m. I would have a 2m minus 3 left, and I just factor that problem. If I look at the next set of problems, I notice I get to the 3 terms. Well, let's see how this works. 3 terms, this is how I factor, and I put all the pluses for you first. First step in factoring, greatest common factor. Do you see any common in those? Nope. Factors of 1 are 1 and 1. And I take the closest factor of 20. Closest factors of 20 would be 4 and 5. Add up to get me a 9. 5 plus 4 is 9. I'm done. And to get a negative 9, they both should be negative. The 1 and the negative 4 I put in one parenthesis. The 1 and the negative 5 I put in another parenthesis. The first variable has z squared. I split that in the first, and there it is. My answer is z minus 4 into z minus 5. I just transformed. So the key, if this is a plus, you must add. How about here? I must add. Add what? Well, is there anything common in those? Nope. 3 and 1. Closest factors of 5. 5 is prime. 5 and 1, 1 and 5. I need them to add. So what's 3 plus 5? Isn't that an 8? Got it. I really don't need this. How do you get a negative 8? Well, negative 5 and a negative 3 because you're adding those. The 3 and the negative 5 I put in one parenthesis. The 1 and the negative 1 I put in one parenthesis. The first has a variable. I split that literally in half. That would be y squared and a y squared. And the last happens to have a variable. I split that in the last. That will be a z, and that would be a z. And there's my answer. If you factor any other way, that's fine. You don't have to do problems the way I do them. Even our author doesn't do factoring the way I do. But since I didn't teach you factoring, I just want you to use whatever you learned. And the same deal, I get to this. That's a plus. I'm going to add anything common in those before I start. Nope. 4 and 1. Closest factors of 4 and 2 and 2. 12 are 4 and 3. So I always start with the closest, see if that works. That works roughly 85% of the time. If I add, that's an 8 and that's a 6. That's 14. That didn't work. Okay, then I try for something else. Maybe I should attempt the 4 and the 1. See how that works. if I go for 4 and 1, and 12, I could say 4 and 3, 3 and 4. If I, again, I'm adding, right? If I add a 12 plus 4, that would be 16. That didn't work. If I take a 16 plus 4, that's not working. How about 6 and 2? That's not working either. If I try for a 12 and 1, 1 and 12, that's a 4 plus. Actually, no matter what you add, it's not going to work. This, and you know, prime is the worst because it really exhausts all the possibilities. So that's prime. That happens sometimes. And let's look at the next problem, number 34. What do you know about 34? Don't skip step number 1. Greatest common factor, 5 divides all of those. 40 divided by 5 is 8x squared. 50, that is what? 10 and 20, 14 and a 3. Okay, I did factor, but not completely. Let me see if that works. If I take the closest factors, 4 and 2, take 3 and 1, 1 and 3, I need them to add to get me 14, right? 6 plus 4 out of the question, but 12 plus 2. A 12 and a 2 do add up to 14, and the reason they add because of that, you want a negative, so they're both negative. The 4 and the negative 1 in one parentheses, the 2 and the negative 3 in another parentheses. Don't forget the 5. The first has a variable, I split that in the first, and there it is. I'm going to finish the rest of the problems in the next video. I'm going to stop here for this video.